You're welcome to this video, and in this class, we are going to learn how to solve a system of simultaneous equation where one of the equations is linear and the other quadratic, and involves the difference of two squares as it is. So let's see how we can approach this problem. So the solution will be p plus q plus 3. You can call this equation 1. Then p squared minus q squared equals 15. You can call this equation 2. Now, it is very important for us to note that there is a problem here, a technical problem here on the second equation, the left hand side of the second equation, where you have a difference of two squares. There are two terms that are squared here. Their difference is what we are going to consider here. So the difference of two squares here is um, uh, we need to apply difference of two squared here, and difference of two squared for p squared minus q squared is equivalent to p minus q bracket p plus q. This is the difference of two squares. So from equation 2, we can then say that this now is equivalent to p minus q bracket p plus q equals 15. Now, if you look at this carefully, this conforms, the equation 1 now has p plus q, and there is a p plus q here. That means we can make substitution. So if we call this equation, if we substitute the value of, of, of p plus q in equation 1 into this equation, we will have p minus q into 3 equals 15. So we can rewrite this to be 3 brackets p minus q equals 15. If we divide through by 3, we'll have p minus q equals 15 divided by 3, which is 5. Therefore, we have p minus q equals 5. We can call this equation 3. We can call this equation 3. Equation 1, equation 2, equation 3. We can then solve equation 1 and 3 simultaneously using any of the methods, whether elimination method or substitution method, because they are terms of the same degree in terms of their unknowns. So solving equations 1 and 3 simultaneously will have something like this. Equation 3 is p minus q equals 5. Equation 3. Now, using elimination method, we can eliminate terms in q. We can eliminate terms in q. How can we do that? If we add them together, we would have eliminated terms in q. So we'll add equation 1 to equation 3, and terms in q will disappear. So equation 1 plus equation 3. So when we add this, we have 2p. When we add this, we'll obtain 0. When we add this together, we'll have 8. So for us to obtain the value of p, we divide both sides by 2. 8 divided by 2, and the answer is 4. Therefore, p equals 4. If we substitute the value of p into any of the equations, we will get the value of q. So we can just choose to substitute into equation 3, for instance. Substituting substituting p equals 4 into equation 3, we'll have, or let's substitute into equation 1, we'll have 4 plus q equals 3. Then q equals 3 minus 4. By collecting like terms, q equals minus 1. Hence, p equals 4 and q equals minus 1. I believe you now understand how you can solve a system of simultaneous equation where one is linear and the other quadratic, involving difference of two squares by you following the approach we just considered now. So if there are questions on as to what I've done or how, or you have any contribution to make, you can drop your comments on the comment section, and I will look at each of the comments and respond to them. Please don't forget to subscribe to my YouTube channel. Thank you, and God bless you.